have an idea.
An idea?
Jesus calls me to reach out and then making the statement that you
All right.
So,
Go fast. I'm about to show you high-tech representation.
I'm trying a guy or something like this. Mr. Anderson.
Oh, okay.
Come on, it's not Guy? Guy Ross. Come on, Guy.
There we go. Hey, would you guys agree that that's a pretty good representation of the region that we're working with? It's exactly root x.
Does this calculator also
over
like
to-
tell you the area? Can you ask it to?
It does. It tells you the volume. So it tells you volume.
So don't tell her about your else.
Yeah, how do you find it? How do you get
How do you what?
How do you get it?
Just GeoGebra. Feel free to use it, but if this is what you rely on, you're gonna be horribly disappointed on the test.
I was just looking at it to
It's just GeoGebra.
to just see the
that.
wait, what was the actual thing
Yeah.
for website and I couldn't get it.
Yeah. So this is GeoGebra. You asked where you get this. It's just
I couldn't find it where on the website. I thought my don't even
we're on GeoGebra. Oh, I don't know. I think I'll probably just search GeoGebra washer method, GeoGebra solid of revolution, something like that. Yeah. Hey, check it out. Let's see if what you have created looks like this. Here we go. What do you guys think? Is that what you got? You said something about the y-axis? Or is it the y-axis? Oh, let's see y-axis then. Sorry.
Oh, mine's really different. Well, in that case, I was wrong.
There we go. Does that work? How about that? I kind of have it rotated sideways. What do you guys think? Is that about what you're coming up with? Can I cut it? Yep. You don't have to be, listen, you don't have to be perfect at it. Oh, wow. What do y'all think from a visual perspective? What do you think? Make sense? Looks good? I believe you. I believe you. Give me a second. Yep, for sure. Okay. So now that you can visualize this, remember the big takeaway from, guys, hey, the Play-Doh is becoming a little distracting. Please. Listen up. From a visualization perspective, there is one big takeaway. And that is, does your solid have a big hole in the middle of it? Could it hold water? Or is it one of those solid solids? What would you guys say? It can hold water. And if it can hold water, what do you use?
Water.
So, turn to your paper there, please, and see if you can set up. Notice it says set up, but don't necessarily evaluate an integral that would give you the volume of the solid as described. So please give that a shot. Check in with you in a minute. Okay, so remember, the big takeaway is this from all the visualization and the Play-Doh and the computer stuff. Big takeaway is this shape could hold water. Tim, are you actively listening to music? Oh, okay. Oh, man. It's become a part of your body. That's okay. Could hold water, and if it can hold water, you have to use washers, right?
Washers.
So, if maybe you remember from yesterday, as soon as you identify washers, before I do any thinking about anything real deep, I'm going to be really basic and say, well, I know that washers look like this. Volume equals pi integral of big radius squared minus little radius squared. And I start there. I don't get hung up on what is the radius or what are my limits of integration or anything like that. I just build the basic framework, the foundation for what I'm going to do, and then I fill in the details. I cannot encourage you enough to take this approach. This will really help you not make a really big error. You still might make little ones. Hopefully we get better at that, but this will get you headed in the right direction. Sir? No?
So you're going to put dy on the end.
Uh-huh.
Does it need to be all parenthesized?
So that is a fantastic question. Let me get there in a second. Let's talk about why it's dy, and then I'll get to your question. So can anybody explain why? I mean, he's right. It does need to be a dy integrand. Why does it need to be that?
Because it's rotating around the y-axis and it's being perpendicular.
The perpendicular relationship, that's right. So if I were to sketch in a representative rectangle, maybe right here, you can see that perpendicularity to the axis of rotation, which is right here, and it's dy thick. Fair enough. So then, are you guys okay with that? That's really what gets you headed in the right direction. So what Jake asked about is, if we multiply by dy, technically does the whole integrand have to be in parentheses? And the answer is yes. If you want to get super technical about it, this should be in parentheses. However, we often don't do that. Often we think of, and this would be okay with me, it'd be okay with just about any mathematician. I would say it'd be pretty rare, even if you saw some like fancy schmancy research mathematician, PhD person, unless they're trying to present it, and that's a big deal, they probably aren't even going to write that. Oftentimes we think of this and this as grouping symbols. And so everything in between is the integrand. But certainly if you want to be technical about it, you're right. Okay. So let me do one little thing here. So I'll go with this. So step 1, write down your framework for washers. Step 2, I kind of like to do the limits of integration. What do you guys think? Accumulation-wise, we're accumulating from bottom to top or left to right? Bottom to top. So what would be my low number for my accumulation start? 0. And where would I stop?
2.
From 0 to 2, I think that makes sense. From y equals 0 to y equals 2 would be my accumulation. And now for my radii. So I am going to represent my big radius with red. So would you guys agree with me that from here to there, that's my big radius, correct?
Yes.
Axis of rotation is the y-axis. The outer edge is that flat surface. So I would say the red line segment would represent that. How far is that? Doesn't it change the whole time? Depending on where you are on the region. That distance will be longer or shorter. What could I put in the parentheses? What could I put in there, but then I'd have to change it? I could put not an x, or not a y, but actually an x. Sorry, I'm mixing my own stuff up. Isn't a horizontal measurement an x? Right? But I can't leave it like that because it's a dy integrand. So it's okay to me thinking like this, but I can't leave it like this. For the big radius, what is x equal to? 2y, right? I would take this and solve for x. So I would replace the x with 2y. And similarly, you guys with me still? Similarly, over here on the right, couldn't I replace, or couldn't I express that inner radius as from purple dot to purple dot? And isn't that just another version of x? But what is that x equal to? Y squared. Yep. So I could replace that purple x with what it's equal to, which is y squared. This would be a fairly straightforward integrand to evaluate, but we don't even have to do that. We all just have to set it up. Could math 9 it potentially. This would probably be one where you'd have to do it by yourself if you had to. What do you guys think? Questions? Any concerns? Okay. So B. These are what we started to talk a little bit about yesterday. I want you guys to think this through. Draw the picture out a little bit. I'm going to do some changing of things up there. This says, write but do not evaluate an expression for the volume of the solid if R is rotated about the horizontal line y equals 5. Feel free to make this with Play-Doh. I'll show you on the computer screen what it looks like too. But go ahead and look at this. Try to make it with Play-Doh. Start to think about what the integrand would be and all that good stuff, and we'll check it out in a little bit. So, discuss. I'll keep saying it until I don't have any more chances to say it. You want to start off by writing volume equals pi, integral, big R squared minus little r squared, and you just start there. Does that make sense, Ellie?
So that is the washer method?
That's the washer method.
Can hold water?
No, so basically there's two fundamental questions. Question number one is this thing just a solid? In other words, there's no hole, it couldn't hold water. If that's the case, you use the disk method. But if I say, hey, does this have a hole in it? And you say yes, then we use washers. If I say, does it have a hole in it? And you say, not really. But then I say, well, could it hold water? And you say yes, still using washers. So if it has a hole or could hold water, then we use washers. If it's just a solid with no hole and water couldn't go in there, then we use disks. But really, the washer method, isn't it just basically a disk method minus a smaller disk method? They're really the same thing. Just one of them has a hole or the other one doesn't. Okay, let's do a few other things here. We're told to revolve this around the line y equals 5. I am going to have to kind of fudge this a little bit. I'm going to say that 5 is up there. We know that it probably should be a little bit higher than that, but I'm going to just say that that's 5. Fair enough? Scaling is off, but you okay? All right. So then if I'm revolving around that, this is where everything gets set as far as my variables. Is my representative rectangle going to be a dy or dx? Why? WHY. Say again? Horizontal axis of rotation and got to have that perpendicular relationship. Does that make sense? So I would draw in my representative rectangle, I don't know, like right here. And it's going to be the tall, skinny variety. It's going to be dx thick. Does that make sense? So I'll just draw this in over here and say it's dx thick. So therefore, my whole integrand is going to be in terms of x. Still doing okay? So sometimes when we do these limits of integration, people get mixed up because this axis has been displaced. The axis is 5. The axis of rotation is 5. But keep in mind, the limits of integration are expressing one thing only. Where do I start accumulating these things, washers in this case, and where do I stop? So for what x value do I start? 0. I start accumulating over there on the far left, and I accumulate all these lovely rectangles. Where do I stop? When x is 4. 2 is a y, 4 is x. So I'd stop accumulating as soon as I get to an x value of 4. Does that make sense? So remember, the limits of integration are tied to what is my pattern of accumulation. Okay, then finally, this is the hard part about these. What are my radii? There's a couple ways to do these. I tend to settle into a very specific pattern. I want to take you through this visually. I think you have the right sense of what you're talking about is about right. But check this out. I'll represent this first one with purple. Would you agree with me that from purple dot to purple dot, isn't that the big radius? Let me bring up some objections. Sometimes people will say, wait a minute, isn't the line the lower function? And wouldn't you have to admit that, yeah, like vertically speaking, the line is the lower function. But remember, the radius is about the concept of distance from axis of rotation to the outer function. And the truth is, even though the line is a lower graph, isn't it further away from the axis of rotation than the curve is? Did I mess something up here? No? Okay. Say it again, Robbie. It's the big R. The purple line is the big R. So check this out. I'm going to take you through this hopefully logically. How far is it from here to here? How far is that? It's 5. Yeah, come on. How far is it from here to there?
5
You know?
minus R.
No.
5 minus.
You need to be super literal. I'm okay with that, but would it be okay if I said that that distance was a y?
Yeah.
So if the whole brown distance is 5 and the orange distance is y, how long is the purple distance, which is the one that we want?
5 minus a certain y.
5 minus a particular y. Agreed. And even though that's nice and everything, why would it not be okay to leave it like that? It's got to be in terms of x because of the dx. For the purple radius, what is y equal to?
2x.
X over 2.
It's y equals x over 2, doesn't it? Yeah, y equals x over 2. So I will erase this, and I will put what that y equaled, and it's x over 2. What do you think? Any questions? Okay, so then would you agree with me then that the gray distance that I'm drawing in, wouldn't that represent the inner radius? That gray distance? Anybody want to take a shot at what you think that little radius would be? What do you think, Sam?
5 minus root x.
5 minus root x is correct. You could say 5 minus y and then say, well, really it's y equals root x, and so we'll go with that because of the dx thing. But that'd be a good place to finish too. Julia.
So, was what we were talking about yesterday, it was when, like, I guess the y-axis was shifted up, but it was still, like, rotated around the x-axis? So there was a whole, like, how did we know?
You're talking about the one I drew towards the end yesterday?
Yes.
So like where the axis of rotation was like down there?
No. It was like, oh, so like number 3. Oh yeah, I guess it was that. It's like the bottom.
So we're going to settle, yeah. So it actually, I wasn't going to say this here, but I think I will. Maybe you probably realize this. Maybe you don't. If I took this and I took this, please watch, because this goes to the heart of your question. Instead of writing 5 minus x over 2, now I'm not going to recommend this necessarily. I'm actually going to do it the other way. But if I wrote it as x over 2 minus 5 and root x minus 5, you guys realize that I would not only have the exact same answer, this would be just as valid. Anybody explain why? Subtracting them in a different order, yes, but I think I heard somebody say it. So think of it like this. Just think of numbers. If I said, hey guys, will you do 8 minus 5? Square the result.
7.
Be serious, because the numerical thing here is important. 8 minus 5 is 3, and 3 squared is 9. What if I said, no, wait a minute. I want you to do 5 minus 8. Now square that. So if you take subtraction and you flip it around, you do get a different number. But if your next step then is to square the result, it really doesn't matter what order you subtracted within the little radii. And so, go ahead.
So like 5 is our new x-axis, basically.
Don't think of it as a shifting thing. Please don't. That will twist your mind up and you'll be like, but I shifted everything, but then I shifted the function the wrong way. Don't shift anything. It is like an x-axis because it's horizontal. I get that. But the x-axis is the x-axis. We're just displacing our axis of rotation to be something other than the x-axis.
Okay, so like if the, if it was from like 1 to 2 instead of 0 to 2, we were shifting, or we were
Okay, hold on. You said it goes from 1 to 2, then 0 to 2, then shift.
No. If it was like, if the function started at 1.
What do you mean the function started at 1? Are you talking about the 0 there?
Yes.
No, okay, this is really important. A huge distinction. So the 0 and the 4, they have absolutely nothing to do with the axis of rotation being displaced. The 0 and the 4 have everything to do with what is my pattern of accumulation.
Yeah.
As I accumulate across the shape, I start at x equals 0 to x equals 4. So the truth is, if was different in this way, let's say instead of rotating around the horizontal line y equals 5, let's say it was rotating around the horizontal line y equals 20, the 0 and the 4 would remain exactly as is. It's just that the 5 would be a 20.
Okay.
Does that make sense?
Yes.
Okay. Great question, because sometimes people get those mixed up. Thanks for asking. Anybody else? Man, I hope you guys are picking this up. We're digging into some really good stuff. Some of you are not handling the Play-Doh as well as I would hope. Go ahead.
So it'll always be, will it ever change?
Will it ever change? This is a little too vague for me.
Yeah, if it has like rotated over a distant line, like this one.
And you're saying the 0 and the 4?
Yes, will the 0 and the 4.
As long as you're rotating around some horizontal, whether it's y equals 20 or y equals negative 60 or y equals negative 3 or whatever, the 0 and the 4, the same.
And if it was rotated over the y-axis?
Well, now you would accumulate from 0 to 2.
But it would never.
Even if you moved it left, the axis left and right, still be the same accumulation pattern.
So you treat those two numbers, like the area that you decide from, you find the area from.
Mm-hmm.
You treat those as if it was just over the x-axis or the y-axis, depending on which line.
Yeah, because it has nothing to do with where the axis of rotation is. It has everything to do with
How you're
on the region, from where to where will I be accumulating. Yeah.
Thank you.
You're welcome. Okay, so guys, C. We're gonna do C and D. So we're gonna pick up the pace just a little bit. So you don't have time to sit there and jack around with the Play-Doh for 10 minutes before you decide to do something. In fact, Robbie, let's go ahead and dispose of it, and maybe Addie, you too. Like, it's not going very well. I'm sad to say. The Play-Doh is becoming an educational hindrance rather than an aid at this point. So, not really a fan of that. So C. I'm going to give you guys a couple of minutes to do this. C says, write but do not evaluate an expression for the volume of the solid if R is rotated around the vertical line x equals negative 3. So this is a little bit different. I'll sketch it in for you. You guys can try to picture it, but I do want you to start working on what might this look like on my expression for the volume. That looks pretty good. Here is a lovely vertical line at x equals negative 3. Can you see the big hole in the middle getting rotated around? Okay. That's the big thing. We got to make sure we see holes if they are there. See cavities for water if they're there, or if it's just a solid. Kind of the only way to make this thing a solid would be to rotate it around the line x equals 2, or x over 2, right? Y equals x over 2. It's going to have a hole in it or water more or less no matter what. That's why I think you should absolutely start out with that basic framework every time. How's it going? You are off to a fantastic start.
Can I ask you, is there any better way to do this, or can I just say I've had 3?
You can go through, I think all of the stuff you're going through right now is really good. It's kind of waiting for understanding it. I'll show you. I think I'm going to do it the same way you are. These distances and all that stuff work.
Mess me up?
I don't think so. But I'm also going to show you a way that you can, I'll formalize it a little bit too. So you can say, oh, if I just do this and this, I'll try to show you both ways and hopefully also why both. But I think it's worth exploring and thinking about why. Okay, looking around, seeing a lot of folks are done with C. Luke is not done with C. You're not quite done with C. C, you're in process on C. You guys have both started off fantastically. You might look at it and say, it's so not that much. No, it is. You absolutely said, I know where I'm going. The details hopefully are going to be okay, but you set yourself up for success. Yes, that's going to be the way that I propose. The way that I'm going to propose axis always do axis minus the appropriate whatever the expression is.
Wait, no.
You okay without your brace here?
Yeah, it's kind of easier. Turning my whole body.
All right, so let's see how this goes. First of all, pretty obvious this thing's going to have a big hole in the middle. So I would set it up like this. Volume equals pi integral big parentheses squared minus little parentheses squared. Now I'm set up for success, right? Is this going to be a dy integrand or a dx integrand? It's got to be dy. What's the relationship between the axis of rotation and the representative rectangle?
Perpendicular.
Always perpendicular, yep. So it would look something like this and that. And of course it's dy thick, so that would be my first piece of the integrand. Secondly, I'm going to be accumulating a bunch of these washers, right? Starting with little tiny washers down there, bigger ones in the middle, and then back to little tiny ones up at the top, right? So what is my pattern of accumulation? I will start accumulating when y is 0, and I will stop when y is 2. You're mixing up your x's and your y's.
Why?
0 to 2. They are y's. I agree. Okay. So then, lastly, and guys, I'm going to try to show you a couple of things, and I think this is all good stuff. Would you agree with me that from purple dot to purple dot is the big radius? I'm going to show you two different ways to do this that are both good. I'll try to formalize it a little bit for you as well. So, how far is that? It changes, doesn't it? It changes depending on where you are. But couldn't you agree with me maybe that from here to there is always the same? It's always 3. That distance is always 3. Okay, so I'm going to say, all right, so the purple distance is going to be 3 plus something. And couldn't I say that from here to here is an x? So for the purple radius, that purple x is equivalent to what? 2y, right? Using the y equals x over 2 relationship. Okay, so I could replace the purple x with 2y. And I've got my first radius set. Then, I hope you would agree with me that from here to here would represent my inner radius, or my smaller radius, right? From axis to curve this time. And once again, from here to here is 3. How far is it from here to there? Once again, it's x, but we know it's a different x this time. So you could put 3 plus x, or you could just put 3 plus y squared. And at this point, you've got both radii correct. You already had the washer method thing set up from the beginning, so you know that's right. And we're good to go. Okay. analyzing all the distances is good, but I want to give you a formula for it, or another way to think about it. Go ahead.
Why couldn't you do the same thing like you did last time? Like
Well, can I present my other way? This might be the way you're thinking. So I want to show you a way that you can avoid all of the drawing of like all these little squiggly things, and this is 3 and this is x and all that stuff. Here would be a way that you could formalize this. This might be useful for you. If you want to just like think about it like we have been doing, I have no problem with that either. If I were doing this question to myself because I was just trying to figure out what the answer is for the quiz key or something like that, or an AP question that I was curious about, here's what I would do. Here's my pattern. I'm going to take the axis of rotation's value, in this case, -3. I'm going to put it here and here. And I will subtract the appropriate expression. So minus 2y minus y squared. And because of the squaring of everything, it really doesn't matter if I'm doing a negative minus something or something plus something. It's going to be the same thing anyways because I'm about to square it anyhow. So that is my pattern. I'm always going to go axis of rotation, in this case it was -3, minus the appropriate expression for the other distance, and I'm done. So I kind of formalize it a little bit just to make it faster for myself.
So if the axis of rotation is positive?
Doesn't matter. This will work whether the axis of rotation is negative or positive, to the above or below, the right or the left. And we can prove it out. We can say, all right, this distance here and this distance here, subtract this and we get this. It doesn't matter if they're on the same side of the x-axis or the y-axis. Either way, still works. Quickly.
Could you rotate it around like x equals 1?
Oh, like something right through the middle of it? Yeah, but we won't. We won't do that.
Then you have to like subtract off of it.
Yeah, it'd be some stuff would overlap.
Then how come you go from like for the problem about y equals 5? How come you went from 5 to 0 when you could just go from 5 to 2 because that's when the y like ends and that's what you did.
The problem, oh yeah, are you talking about the previous example?
Yeah, so in the previous
Hang on
example,
1 second,
you
hang
went
on.
from 5 to
Sorry,
this
I know I'm
one.
interrupting. Stop.
So you didn't go
Stop.
4.
Stop.
Stop it.
I'm going to come talk to you. Will the rest of you guys please try D right now? Ready, go. Please try D. Look like, before we go, hopefully you're able to get something decent there. Y equals -2 would just be down here. Guys, hey, I know it's about time to go. Let's finish well. Y equals -2 is down here. Here's what I would do. Number 1, hey guys. Number 1, there's a hole. So I'm going to say washers. Volume equals pi integral big R squared minus little r squared. I also know that I'm perpendicular to my axis of rotation, so it's dx, right? I'm accumulating from left to right, so it's 0 to 4. And then I'm going to use my little formalization of this. I'm going to say axis of rotation minus, axis of rotation minus. And then the further away function is the curve, and the curve was root x, I think. The closer, the inner function was x over 2, so it'd be minus x over 2. Done. So if you formalize it like that, it can be pretty quick. Thank you guys. Tomorrow, we'll enter the final phase of volume, and we're done.
Thank you.
Yay. Have a good day.